Hi everybody, this is Math 024 Module 2. We're going to talk about polynomials, polynomial operations, and later on, actually this will be Module 3, we're going to talk about applications of polynomials. So to start off, a polynomial is a finite, which means it's not infinite, so it ends, so it has a certain number, sum of terms in which all the variables in each term have whole number exponents. So the exponents on the variables have to be whole numbers, so they have to be positive. And then a polynomial has this general form here that you see here, where really what this means is it's going to start with, when you write out a polynomial, you'll want to start with your highest degree or your highest power for that variable, and then move down from there until you get to this last term where you will have a constant term, so the variable won't be present, or it will be to the 0 power. And you'll see as we look at polynomials kind of what that form is as we go through. Now, there are different terms that I've kind of already used in the first video, but for polynomials, it is a finite sum of terms. A term is the product, so again, the answer to a multiplication problem, of a number and variables raised to powers. So that is what a term is. A term with no variables is called a constant term. And sometimes I had a coworker that used to say it's constantly alone because there's no variable there to change it. Now, when you have a term, something like, 5x squared, the numerical factor or the number part is called your coefficient. Okay, so the 5 there, that's our coefficient. And then you have different names for polynomials. So if you have a polynomial with one term, just like this 5x squared, that's one single term, that is called a monomial. Okay, so it's a monomial term. A polynomial with two terms, so something like 5x squared plus 2x. Okay, two terms. Terms are always held together or separated by addition or subtraction. So I know I have two terms here because I have that addition separating them. And that is going to be a binomial. And then a polynomial with three terms is called a trinomial. Okay, and our trinomials, an example would be something like, 3x squared minus 2x plus 7. And again, that's 7 right there because it doesn't have a variable. That's our constant term. And then the other two, one term, here's the 3x squared, separated here by subtraction, but we can always write it as addition of the opposite. So think polynomials, the terms are separated by addition and subtraction in there. So those are some terms to help us with this unit. So here we're just going to look at some polynomials, see if we can name them, look at the different terms, what are the coefficients, what are the constants. So really looking at all those vocabulary terms and all of those parts. So this one, it kind of got smushed a little bit in there, but the polynomial is 3x squared minus 5y plus 16. So if we look at this, I have 1, 2, 3 terms. So because I have 3 terms, it is a trinomial. All right. The terms, they just want you to list them separately. So we have, again, our first term was our 3x squared. Then the next one, it's negative 5y, because you want to look to that sign to see the sign of the number. And then also 16. Because remember, 16 is a term. Our coefficients are the number part of the terms. So again, 3, and then again, that 5, because it's a minus 5y, it's a negative 5 for my coefficient. And 16 is also a coefficient, but it is also considered a constant because it has no variable. It's constantly alone. All right, now for the second one, I have one term here, so that is called a monomial. All right, my term is only negative 4a squared. Okay, the coefficient, again, the number part is negative 4, and there is no constant. There's none that's alone, so that would be NA. All right, for the second part, we have x minus 10, or the last one, I should say, and this has two terms because they're separated by subtraction. So this is a binomial. Sorry, my A's are a little crazy today. The terms would be x and then negative 10. Now, the coefficients. In front of that variable, that x, there is a number. If we don't see it, there's always a number there. Remember, it's a product, so 1 times x is the same as x. So our coefficients here are 1 and negative 10, and then my constant is negative 10 because that is the one without a variable. Next, we are going to look at the degree of a term. And you may have mentioned, or you may have heard me mention in the first slide, I talked about the degree of the polynomial. So the degree of a term is the sum of all the exponents with variable bases. So again, you're looking at all the variables in the term, and you're adding up those exponents. Only the variable parts, not the number parts, if they have exponents. So if we look at A here, and they ask us to give the degree of the term, we only have that x squared there. So the degree of the term is 2. So the degree of that term is 2 because it's x squared. Now for B, we have one variable here, and it's A. Now there's no exponent on it, but remember, if we don't see it, that exponent is a 1. So this has a degree of 1. And for C, it's 4 to the 5th power, but we're looking at the sum of all the exponents with variable bases because I don't have any variables here. The degree of this term is 0. It has a degree of 0. All right, so next we're going to look at the degree of the polynomial. So in order to find the degree of the polynomial, we are going to look at each term in the polynomial, and the degree of the polynomial is the term in the polynomial with the highest degree. So we're going to look for that highest degree. So if we look at our first polynomial here, notice we have two terms, so it is going to be considered a binomial. And I want to look for the highest degree. So this first one has a degree of 2 because it's x squared, and that's my only variable with exponents on that term. The second one has a degree of 4 because it's x to the 4th power. So the degree of the polynomial, again, is the term with the highest value. So it is the degree of 4 here. Okay, next for the next one term here. So again, it's a monomial. So whatever the degree of the term is, the degree of the polynomial, because it's p to the 2nd power, and that's the 2, that's our degree of 2. Now for the third one, we have 3 terms here. So it's a trinomial. And if you notice, each of these, like the exponent on the variables, we don't really see it, but remember it's that invisible 1. If we don't see it, it's a 1 that's there. So the degree of this trinomial, each term has a degree of 1. If your degrees are exactly the same, and that's the highest, then it's just going to have that same degree. So it's going to be a degree of 1. All right, so now we are going to look at addition and subtraction of polynomials. So we're going to start with our operations on polynomials. And so to add or subtract polynomials, you're going to use the same rules as you do when you combine like terms. Let me move this back up real quick. All right, same rules as when you combine like terms or terms, okay? So the nice thing is if you have addition on your problem, really all you're doing, again, when we are adding terms together, we have to have like terms. So remember, like terms mean that I call it the last name, the variable and the variable exponents have to be exactly the same, and you add those coefficients. So if I look at this problem, I have 3x squared and 7x squared. So the x squared is the same. I'm just going to add the coefficients. So 3 plus 7 will give me 10x squared plus or minus, let's see. Next we have 5y squared and negative 12y squared. So negative 12 plus 5 will give me negative 7y squared. And then our constant terms are negative 7 and negative 15. So if I add those together, it's going to give me negative 22. And that will be our final answer there, 10x squared minus 7y squared minus 22. Now with B, when you have subtraction, it is a little bit different. We do have to do one thing that we're not quite used to, and that is that negative sign is on the outside of those parentheses. So that means you have to distribute, think of it like this, distribute a negative 1 to everything on the inside. Or that negative sign or subtraction sign outside the parentheses means to change the sign of everything on the inside. So let me just erase that real quick and make it a little bit clearer. So again, what I did is I made it plus a negative 1, and we're going to distribute or multiply everything in there by negative 1. So our problem becomes, we have 6a squared minus b cubed, and then a negative times a positive will give me negative 10a squared. Two negatives give me a positive 5b cubed, and a negative times a positive will give me a negative 6b squared. And we are going to go ahead and combine like terms now that we've distributed the negative. So we took care of that subtraction part. Now it's just combining like terms. So we have 6a squared and negative 10a squared. So that's going to give me a negative 4a squared. We have negative b cubed and positive 5b cubed. So negative, remember there's a 1 there, so negative 1 plus positive 5 will give me a positive 4b cubed. And I don't have any other b squared terms, so we're just going to tack it on the end, minus 6b squared. And again, none of my variables are the same. I have a squared, b cubed, and b squared. And because the exponents on the b's are not the same, I can't combine them. So that is my final answer. Okay, so now we are going to do another addition problem, and we're going to add 10c squared plus 8 to 13b squared plus 12c squared minus 22. So again, think of that word 2 as like that plus sign there. So let's combine like terms, 10c squared, and then we have 12c squared. So 10 plus 12 will give me 22c squared. And then I have a 13b squared, but there's nothing else like it, so I'm just going to write it there because I don't have anything to combine it to. And then we have 8 minus 22. So if I do 8, positive 8 minus 22, I end up with negative or minus 14, negative 14. So our final answer is 22c squared plus 13b squared minus 14. All right, now D is a little tricky because they asked us to subtract 7m cubed plus 2n squared from m cubed minus n squared. So think about subtraction. If I say subtract 5 from 10, what number comes first? Hopefully you're like, ooh, 10 comes first, and then you subtract 5. So here, because I'm subtracting this expression from this expression, when I write it out, it's actually going to be, not n squared there, but it's going to be m cubed minus n squared minus, and then the other expression, the 7m cubed plus the 2n squared. And then again, here we have to do our distribution of that negative. So again, make it plus a negative 1 and then distribute that negative 1. So we're going to end up with m cubed minus n squared. And again, a negative times a positive. So negative 1 times positive 7m cubed will make it negative 7m cubed. And a negative 1 times a positive 2 will make it negative 2n squared. Now that we've distributed that negative, all we need to do is do our combine like terms. So we have m cubed and negative m cubed. So remember there's a 1 there. 1 minus 7m cubed will make it negative 6m cubed. And then we have negative 1n squared and negative 2n squared. So negative 1 minus 2 will make it a negative 3n squared. And that is our final answer because these are not the same variables. We can't combine them. They're not like terms. So that's really it for adding and subtracting. It's just reviewing those combining of like terms and going over things. Up next, we will look at multiplication. All right, so now we are going to work on multiplication of polynomials. And in order to multiply polynomials, you multiply the coefficients, so the number of parts, you multiply them. And then you use the power rule of exponents to simplify the variables. So you use that power rule. Remember, you add those exponents. So, for instance, for A, multiply the coefficients. So we're going to do just 8 times 7 like we would normally multiply it. And we know that 8 times 7 is 56. And then look for our like bases. So we have x as our like basis. We have an exponent of 2 and an exponent of 4. So remember, the power rule says you add those exponents when you multiply bases that are the same. So it's going to become 56x to the 6th power. And that's our final answer for that one. Now for B, because we have the parentheses there, this is a problem where we're going to use our distributive property. So we are going to distribute or multiply the 4y squared to each of the terms on the inside. So we'll do it just like we did A, but we have 2 pairs of terms to worry about. So for the first one, for 4y squared times 2y squared, I'm going to do 4 times 2, and that's going to give me 8. And then y squared times y squared, add those exponents. It's going to be y to the 4th power. Then I'll put my subtraction sign there. I'll do 4 times 5 next, which is 20. And then y squared times y. Remember, there's a 1 next to that y, so it's going to be y to the 3rd power. And I can't do anything else because y to the 4th and y to the 3rd are not like terms, so I'm done. I can't do any more multiplying or adding or subtracting because they're not like terms. All right, for C, again, we're going to do the same thing. We are going to distribute, but now we have 3 terms on the inside. So we're going to distribute the negative 3a to the 4th to 6a cubed, to negative 4a squared, and to positive 10. So again, for C, negative 3a to the 4th times 6a cubed. Negative 3 times 6 is going to be negative 18. A to the 4th times a cubed, add 4 and 3, so we get a to the 7th. Now, negative 3 times negative 4, 2 negatives make that a positive 12. And then a to the 4th times a to the 2nd is going to give me a to the 6th power, because 4 plus 2 is 6. And then negative 3 times 10, positive 10, is going to be negative 30. A to the 4th, there's no other variable here, so we'll just tack that a to the 4th on. And that will be my final answer because, again, there aren't any like terms, so I can't combine anything, so that is done. All right, and here again, we are going to practice that distributive property in multiplying. So now we're going to multiply 10x squared y times 2xy times 7x squared and times a negative y. So 10 times 2 is going to give us 20. And then we have x squared and x. So those are like bases. Remember, there's a 1 on that x. So that's going to give me x to the third power when I add my exponents. And then we have y times y. And those are like bases. And the exponent on those is a 1. So when you add them together, you get y squared. Plus, then 10 times 7 is 70. X squared times x squared will give us x to the fourth power because we add those exponents. And then there is no other y over here, so we're just going to tack it on. There's no y to combine exponents with, so it just continues with a y. Now for our last term, it's a negative 1y. So our answer, we have a positive value and a negative value. So our answer is going to be negative. So negative 10, or 10 times negative 1 will be negative 10. We have no x terms, so it'll be x squared, and then y times y will give us y squared. And that will be our final answer for D. Now for B, again, we're going to distribute the 5b squared to each of the 4 terms on the inside. So first we have 5b squared times 2b cubed. 5 times 2 is going to be 10. B squared times b cubed is going to give me b to the fifth power because we add those exponents. Now, 5b squared times 6b, that is going to be 5 times 6 is 30. B squared times b squared is b to the fourth. 5b squared plus 7b cubed, so 5 times 7 is 35. B squared times b cubed is going to give me b to the fifth power. And then 5b squared times negative 1b, or negative b, is going to be negative or minus 5, because 1 times 5 is 5, b cubed, because I'll add the 1 and the 2 together. Now, with this problem, if you look, we do have one thing that we can do. I have 10b to the fifth power and 35b to the fifth power. Those are like terms, so I can add those together, combine those like terms. And 10 plus 35 will give us 45b to the fifth power. Then we'll keep our plus 30b to the fourth minus 5b cubed, and we can't do any more, so that would be our final answer there. Okay, so now we are going to multiply 2 binomials. And one little trick you may have heard to help you remember how to multiply binomials, 2 binomials is, fix that real quick. Okay, is FOIL, F-O-I-L. And FOIL stands for first, outer, inner, and last. So when I go to FOIL, or multiply, first thing I'm going to do is multiply my first terms together. So the first terms will be the first one in each binomial. So example for A, it would be 3x times 5x. So again, do 3 times 5, we get 15. X times x will give me x squared. O stands for outer. So our outer terms are going to be the ones on the outside. So 3x and negative 3. So 3x times negative 3 will give me a negative 9x. Inner stand for the inner 2 terms, so the 2 on the inside. So 2 times 5x will give me a positive 10x. And then last are the ones that are last in the 2 terms, so 2 times negative 3, and that's going to give me a negative 6. Now you do want to check to see if you can combine like terms, and I can in the middle here. So when I do negative 9 plus positive 10x, my final answer is going to be 15x squared. Negative 9 plus positive 10 is going to give me positive 1x, or just x. So you can write 1x or just x, so plus x, and then minus 6. And that's our final answer there. Now for the next one, we are going to FOIL again. So we're going to do the first terms. So 2x times 2x is going to give me 4x squared. Then we're going to do the outer terms. So 2x times 3 will give me a positive 6x. Inner terms will be negative 3 times 2x, so minus 6x. And then last terms, negative 3 times positive 3 is going to give me a negative 9. And when I go to combine like terms there, for this one, you're going to notice something is going to happen. Positive 6x and negative 6x equal 0. They cancel out. So then our final answer here is just going to be 4x squared minus 9. This is called a perfect square binomial. You might see them, you'll see them more in 025. We'll talk about them more there. All right, and let's look at our last one to FOIL, at least on this page. So we're going to start off with our first terms, and that's x times 2x. So we're going to get 2x squared, and then x times 4/5, so it's going to be plus 4/5 x, and then negative 2/5 times 2x. So I'm going to do a little work down here. Negative 2/5 times 2x. Remember, think of it like that 2x is over 1. So our final answer here is going to be negative 4/5, and then I'm just going to put the x to the side. So we're going to have negative 4/5 x. And then our last two, we have negative 2/5 times 4/5. So again, you multiply straight across with those fractions. Negative 2 times 4 is negative 8. And 5 times 5 is 25. So we're going to have negative 8 over 25. Now with this one, again, in the middle, I have two of the same terms, but they're a positive and a negative. So positive 4/5 x and negative 4/5 x. So those are going to cancel. And my final answer is going to be 2x squared minus 8/25. All right, next we are going to look at a binomial, so two terms, that is squared. Now, when you see a problem like this, you need to solve it a certain way. For this problem, we are squaring not just each term on the inside, but we are squaring this whole expression. So they're squaring the whole thing. So remember, that 2 tells you how many times what's in the parentheses has to be written in the problem. So because we are squaring the expression 2a minus 3x, to do the math problem, in order to get it correct, you have to write it out. So it has to be 2a minus 3x times 2a minus 3x. Because this is an expression, meaning it has that addition or subtraction sign in there, you can't take the 2 and distribute it. That would be wrong. You have to write it out twice and FOIL it. So now we're going to do our first terms. 2a times 2a will give me 4a squared. And then 2a times negative 3x for our outer terms is going to give me negative 6ax. The inner terms are going to be a negative 6ax. And then my last terms, two negatives make it a positive 9x squared. In my middle terms, they don't cancel out because they're both negatives, but I can combine them. So I'm going to have 4a squared minus 12ax plus 9x squared for my final answer there. Same thing with e. I need to write it out, expand it, write it twice. So I'm going to have 5x squared minus 4y squared times 5x squared minus 4y squared. All right, now we are going to multiply our first term. So 5 times 5 is 25. X squared times x squared is x to the 4th. 5x squared times negative 4y squared is going to give us negative 20 x squared y squared. inner terms, negative 4 times 5. Negative 4 times 5 will be negative 20 again. And we'll have x squared, y squared. And then the last terms, two negatives, are going to make that positive 16. And it'll be y to the 4th when we add those exponents. Now again, those middle two terms are like terms, so I can add them. And negative 20 minus 20 is going to give me 25x to the 4th minus 40x squared y squared plus 16y to the 4th. And that will be our final answer for that one. All right, next we are going to be multiplying a binomial times a trinomial. So really this is kind of like an extended distribution problem. So first we're going to start off and we're going to multiply the 3x times each of the terms on the inside of that trinomial. So I'm going to do 3x times 3x squared first, which is going to give me 9x to the 3rd power, because 1 plus 2 is 3. Then I'm going to do 3x times negative x. So again, remember that's like a negative 1 there. 3 times negative 1 will give me negative 3x squared. 3x times 2 is going to give me plus 6x. Now that we've done the 3x times everything, we're going to do negative 4 times the 3 terms on the inside. So negative 4 times 3x squared will give me negative 12x squared. Negative 4 times negative 1x, two negatives make that a positive 4x. And negative 4 times positive 2 will give me a negative 8. And then the last thing you want to do is see, can we combine like terms? And we can in this case. I only have one cubed term, so we have 9x cubed. And that's minus 3x squared and minus 12x squared. So it's going to be minus 15x squared. And then we have x's, so plus 6x and 4x, so plus 10x. And then plus 8 will be our final term there. Okay, and let's take a look at B for this one. Now, I would say you could do the trinomial times the binomial, but I think I'm going to go in reverse. It's easier to work with the two terms and multiply it times everything in the third one. So I'm going to do first y times 4y cubed. So it's going to become 4y to the 4th. Then y times negative 5y squared would be negative 5y cubed. And negative 1 times y will give me negative 1y or negative y. Now we're going to do 2 times everything. So 2 times 4y cubed is going to give me positive 8y cubed, negative 10y squared, and negative 2. Now combine like terms. So again, there's no other 4th term, so it's going to be 4y to the 4th. But the y cubed, I have negative 5y cubed and positive 8y cubed. So if I add negative 5 and positive 8 together, I'm going to end up with positive 3y cubed. And then I really think we have a y squared, so I'm going to write the 10y squared, but there's nothing else that matches it. And minus y and minus 2. So that is it. And it is, if you notice, written in descending order, so the highest degree is first, and then you go down until you get to that constant term. All right, we're down to our last two problems. And if you notice, for C, it's x plus 3, the expression cubed. So again, just like when it was squared, you wrote it out twice. Since it's cubed, we're going to write it out 3 times. So we're going to have x plus 3 times x plus 3 times x plus 3. Now, when we multiply, you multiply 2 things at a time. So that's what we're going to do. We're going to work on this 2 things at a time. So I'm going to start off, and I'm going to FOIL the first 2 expressions. So x plus 3 times x plus 3. I'm going to put it in parentheses, though, so I know I need to continue. So it's going to give me x squared plus 3x plus 3x plus 9 times x plus 3. But what I'm going to do is combine like terms in the middle. So I'm going to have x squared plus 6x plus 9 times x plus 3. And now, just like we did on the last slide, I'm going to multiply the x times everything on the trinomial first. So x times x squared is going to give me x cubed plus x times 6x is 6x squared. 9 times x is 9x. Now I'm going to multiply the 3 times everything on the inside in the trinomial. So 3 times x squared will give me plus 3x squared. 6x times 3 will give me plus 18x. And 9 times 3 will give me 27. Now we are going to combine like terms. So we only have one x cubed, so it'll be x cubed plus, we have 6x squared and 3x squared. So that's going to give me 9x squared. 9x plus 18x is going to give me 27x, and then plus 27. And that would be our final answer there. All right, let's take a look at the last one for this video, and the last one we're going to deal with multiplication. In video part 2 for 024 module 2, we will look at the division of polynomials. All right, so two trinomials. So again, we just have to take each term in the first one, multiply it times each term in the second one. So I'm going to start off, I'll do 2x squared times x squared. So that is going to give me 2x to the 4th power, because x squared times x squared, 2 plus 2 is 4. 2x times negative 3x is going to give me negative 6x cubed. 2x squared minus 5 is going to give me negative 10x squared. All right, I might not have enough room to write it all out. Let's see, now we're going to do 4x times each of the terms on the inside. So 4 times x squared, 4x times x squared will give me plus 4x cubed. That's a 3. 4x times negative 3x will give me negative 12x squared. And 4x times negative 5 will give me negative 20x. And I still have to multiply everything by that 1. What I'm going to do really quickly, though, I'm kind of running out of room. So I'm going to combine any like terms that I can right now. And then I'll do that again in a second. So I don't have any other 2x to the 4th. But I can combine my cubes. So negative 6x cubed and positive 4x cubed is going to get me negative 2x cubed. Negative 10x squared and negative 12x squared will give me negative 22x squared minus 20x. And now that 1 times everything on the inside of the other one is going to give me plus x squared minus 3x and minus 5, because it's 1, so it's really repeating everything. And again, now I'm going to combine like terms again for my final answer. So I only have 1/4 term, so 2x to the 4th. I don't have any more x cubed, so it'll be minus 2x cubed. I have negative 22x squared and positive x squared, so that's going to be negative 21x squared, because it's negative 22 plus positive 1. And then negative 20x and negative 3x will give me negative 23x, and then my minus 5. And that, it's a long problem, but that is our final answer. There aren't any like terms, so we can't combine anything, so that's our final answer.